Baxley, what are you doing?
Well, I have these interest surveys that the students fill out about things they're interested in, and I'm trying to decide how to organize them. I don't know whether I want them by things they're interested in, or by class period, or alphabetically.
This is so funny because you know what? This is the way Mendeleev developed the periodic table.
You know, you're right. He was a teacher, right?
Yes.
And he couldn't figure out how to kind of organize it, so he put the elements on little cards and laid them out and organized them so he could figure out how they made sense.
Right.
Excellent. All right, so here we have Mendeleev, right?
That's right.
Where was he from?
Russia.
Ah, Dmitri Mendeleev.
Yes.
Good
Doesn't
Russian
he
name.
look Russian?
He does. You're right.
Stern.
And what a beard.
It's a weird beard, isn't it?
It is. It is. And what do you think we've got here?
This is his first periodic table that he put together. And it's kind of difficult to see, but you can see, for instance, rubidium right there. And he's placed it in energy level, well, I can't read Russian, so that isn't very good, is it? It's right there. And strontium is next to it, which is the way it is on the table now, right? Rubidium is 37 and strontium is 38, and they're in row 5. And right above them is calcium and potassium, and that's the same thing on Mendeleev's chart. And sodium's above potassium, and magnesium's above calcium.
Now, why are there some blank spaces here?
Well, those were elements they hadn't discovered yet, but Mendeleev knew that there had to be something that would fit in those blanks.
Fascinating. So he predicted that there would be something that would go there.
Yes.
And as I understand it, there was another guy named Lothar Meyer from Germany who made a periodic table about the same time.
Ah.
But he never made any predictions on it.
Okay. So Mendeleev was the one who got the recognition for
exactly
for the
because
table.
He made a prediction. He was bold. He was bold enough to say, "I think something's going to go here." The things were then discovered and proved to be correct. But because Lothar Meyer made it up, but never made a prediction with it, he's known for it.
He's not known for it.
Nope.
I didn't even know that. So there, I've learned something new today.
Okay.
Okay, let's see, what do we have next? So there's Dmitri Mendeleev. He made the first periodic table in 1869. He set it up based on increasing atomic mass, which...
well, is that really right for everything?
It's not quite right for everything, because if you look particularly right around, I believe it's cobalt and nickel, cobalt is actually heavier than nickel, but it's listed before nickel because it only has 27 protons, and nickel has 28.
A proton. What is periodicity mean?
Periodicity is the study of the trends of the periodic table. So what we're talking about is, if you know the word periodical, what does that mean?
That's on occasion a regular amount of time between.
Okay. The media center gets periodicals.
Right.
So
Maybe
those,
once a month.
Right.
Every
so
month.
Those are magazines that might come once a month, once every 2 weeks.
Right.
Okay. So what Mendeleev did is, not only did he arrange by increasing atomic mass, he arranged by properties of each of the elements and how they repeated.
Okay. Very good. So we see, for the whole big idea for this whole unit here, that periodic trends in the properties allow us to predict physical chemical properties. Okay.
Yes.
Very good. Now, you mentioned that things are done by protons now.
Yes, and Henry Moseley was a British chemist who discovered in 1914 that if you arrange the elements by atomic number, then their properties followed more closely and followed the periodicity more closely.
And that's what we still have today. They're arranged by atomic number.
Right.
Number of protons.
And Henry Moseley was a very intelligent man, and he was unfortunately killed in World War I.
Oh, how tragic.
And it's very interesting because he had some very unique and ahead of his time ideas, and it makes me wonder sometimes what might he have discovered if he had not succumbed in World War I.
My goodness. All right, so the periodic table was developed, and it didn't all come about at the same time.
Right.
So, in fact, it's still developing.
It is, because we're still finding new elements.
Okay, and the new elements we're finding, they're not naturally occurring, are they?
They're not naturally occurring. In a way, it's kind of funny for me to see them on the table because they're made in the super collider in CERN, and they last for a trillionth of a second.
Okay, so
And
if you've got a big, a great big giant atom, and they hit it with another thing, it's going to make a bigger thing, but it's not going to be real stable.
Right.
So then it's going to break into smaller parts.
Right.
Okay, so it's not very stable, doesn't last for very long. They have detected them.
Right.
So they can say they exist on the Earth, but
right.
not for very long.
Not for very long. I mean, it's usually like way less than a second.
Okay. So they're really not good for a whole lot other than just interest. And at this point, they're not good for a whole lot.
Exactly. But one day they could very well be of value. So periodic law says that our physical and chemical properties of the elements are periodic functions of atomic number. So basically what that means is we go across the period or the row of the periodic table. Say we start with lithium, and then we go across, and then we come down to the next row, starts with sodium. Lithium and sodium have similar physical and chemical properties.
Okay, and I'm going to just skip ahead a little bit. We see that, as you say, going down, so all these things going down, you're telling me are similar, right?
Yes,
Okay.
yes. So what happens as you go across the period is each time you go to a new box, each column has the same similar physical and chemical properties.
All right.
Okay? As you're going, each of those columns, those elements in those columns have similar chemical and physical properties.
All right, and we'll get to see some of those different names for those in a little bit.
Yes.
Okay.
All right. So, and the other thing is that we've just learned is that the elements are arranged, therefore, by the blocks for their electrons orbital filling. So our first two columns or groups are our s electrons.
Yes.
And our last 6 are our p electrons. Those middle 10 are our d electrons. And then in the bottom 2 rows, the lanthanoids and the actinoids are our f electrons.
Excellent. So it says the energy level of an element's valence electrons tells us what period.
Right.
So if they have 4 energy levels, it's going to be in the 4th period.
Right.
All right? 2 energy levels, it'll be in the 2nd period.
Yes.
So let's see, there's 7 periods, right?
Yes.
There's 7 periods in our class day.
Oh, I never thought about that.
Yeah, but you know what? Yeah, 7th period seems a lot more energetic to me than 1st period.
It sure seems to drag a lot longer, doesn't it?
That's right. And now when we get, I know there are different ways to number periodic tables. Some of them have these A's and B's and Roman numerals, and some of them have just 1 through 18 going all the way across.
And on the ones on the walls in our rooms have the 1 through 18 in the red. But then there's also numbers underneath them that are Roman numeral numbers. And those are the ones I like to use because they help relate the number over the column to the number of valence electrons in that column.
I like that. It's easier too. And we'll see that more as we go along. All right. Now this is kind of like a chopped off periodic table, leaving out the transition elements. But as we see here, okay, here are our period numbers, and it's leaving off 7 as well. There are 7 periods, like we've got 7 periods in the day. And electron configuration, going up and down now, talking about our groups or families.
Right.
So this group has 1 valence electron, 1, 1, 1,
Right.
1, 1, 1.
Right. And then
Group 2 has 2, 2, 2, 2, 2, 2.
Right. And we
This
skip
is the 2s, 1s,
2s. We skip the transition and we go over to the other side where our p electrons are.
All right, so this has got 2s and 1p for a total of 3
Right.
valence electrons.
Now notice that there's a 13 on the top of that periodic table.
Okay, this is what we were talking
and
about.
this is the number in red you'll see on our periodic tables on the wall.
Okay.
But underneath those red numbers are Roman numeral numbers in black. So underneath the 13 we have a 3 with a B, but I just call it column 3.
Right.
And
this
then
would be
4B, 5B,
B,
6B, and 7B, and 18 is just VII. Yeah, there's no B.
Okay.
But what I like to do is I like to think of that row 13 as being 3 because there's 3 valence electrons, right?
Right.
And 4B then becomes, oh, I like how you're doing that. There you go.
We'll just pretend that
Yeah.
one isn't there.
Exactly. Let's take the 1 away. Perfect. I love it.
All right. And then
Okay.
we'll see how many valence electrons.
And so column 3 has 3 valence, column 4 has 4, column 5 has 5, column 6 has 6, 7 has 7, and 8 has 8.
Nice.
So it works out really nicely to be able to look at the table, and you don't even have to figure out your S&P electrons. You just can look at the column, and you know the valence
It's like the
electrons.
world's greatest cheat sheet, isn't it?
It is so incredibly spectacular. I tell my students that on the first day of school that by the end of the semester they're going to come into the classroom and they're going to know so many things about that table and that they don't know now. And they've already learned so much.
That's right.
That's just kind of like a summary of the periodic table. It's the complete chart of all the elements in the universe that we know. And it's arranged according to chemical and physical properties as well as the atomic number. And usually, every periodic table is different.
I've noticed that.
But
it gets a little confusing
yeah,
sometimes.
but usually you're going to have the atomic number, the atomic mass, and the chemical symbol.
Okay.
At least that. And I have one at home that gives like the electron configuration and properties of the element, and so you can have as little or as much information on a periodic table.
A nice thing like a map is it usually has a key.
Yes.
So that's very helpful.
Yes. Okay, so how do we organize these? We have groups that are the columns that run up and down vertically,
Okay.
and these are the where the similar properties come through.
All right, so we have our first group here going
Yes.
up and down. Now, hydrogen is kind of odd because it doesn't really fit with this group, right? Okay.
It doesn't, and there's a lot of debate actually in the chemistry community as to where hydrogen should be on the periodic table. And I've read a number of articles that have talked about hydrogen should really be above fluorine next to helium because it exhibits more of the halogen group properties than it does anything else.
Well,
But-
they've got it here for now, but we'll just pretend it's
Right.
not here because this group has a name.
Yes.
All of these coming down here have similar properties.
Exactly.
And so what is the name of this family going down here?
Okay. Well, first of all, we call it Group 1.
Group 1.
Okay, it's Group
Okay.
1. And Group 1 is the alkali metals.
Alkali, and they are metals.
Mm-hmm.
Okay.
And they are highly, highly reactive
Okay.
because they have 1 valence electron.
Oh, yes. And I bet it doesn't want that one. It wants to try and get rid of it any way it can.
That's right, because if it gets rid of it, then it has a full valence shell underneath.
Okay, very good.
So it really wants to get rid of that 1 electron.
Okay. And I think we're going to talk about more properties a little later on
Yes.
too, right? So right now we're just introducing.
Yeah, introducing.
Very good. We got alkali metals.
Okay.
Now we've got group 2,
Which we call the alkaline earth metals.
alkaline, like alkaline batteries.
Like alkaline batteries. Okay, and again, those are our fairly reactive metals as well, because they only have 2 valence electrons. But we'll discuss that more when we get to the group information.
Okay. Now this is kind of going across right here. A lot of times we skip from these two all the way to the right, but this one has a name too, right?
That's the boron. We call it the boron family.
Oh, that one's easy because it just has boron on the
it's
top.
boron on the top.
Okay. And as we said before, this has 3 valence electrons, even though it's in group 13.
Right.
Okay.
Okay.
And the next one,
Next one is the carbon family.
I like that one. E2, that one's easy.
Easy.
Because carbon is on the top.
Right.
But you're saying that all these things below carbon have somewhat similar properties?
Yes.
All right.
Yes. And then we get to group 7, which is the nitrogen family.
Again, easy. We don't have the atoms family, do we?
No, we don't.
You're sure we don't have
That's-
the atoms family?
I know what you were
Okay.
saying. That's a good pun.
Very
I
good.
like that.
Okay, nitrogen family.
Okay. Now, our next group, actually, we call it the oxygen family because obviously oxygen is at the top. But it also has another name. It's called the chalcogens family. I don't even know if I'm pronouncing it correctly.
Okay.
But we call it the oxygen family. But sometimes you'll see it referred to as CHAL, I believe COGENS, something like that.
Okay. It looks like it ends in oxygen.
Yeah, but so if you see that, then you know that it's the oxygen family.
Okay.
All right.
Now this one I know does have a different name.
That one has a different name, and we call those the halogens.
Halogens. I've heard of halogen lights.
Yes.
In your cars.
And the halogens are also very reactive because they have 7 valence electrons, and they very, very badly want that 8th electron. Okay, so we'll talk about that some more.
Okay.
And then last but not least is our noble gases.
Noble sounds so
regal.
Yes.
And king-like.
It does.
But our noble gases have full valence shells. They're not usually very reactive. In fact, most of the time they don't react at all. But you can get them to react, but it's under very specialized conditions to get them to react.
Okay, so we could say they are mostly unreactive?
Yes.
Okay.
Because
or not very reactive.
Because they have a full valence shell, and they're like, I'm happy, leave me alone.
Nice.
Okay.
All right, so our periodic table.
So there we are.
And we will continue with this later. How about that?
That sounds great.
Okay. See you soon.
All right.